So this is for homework 5, written part, the non-conceptual questions. The first problem, you have a bunch of steel balls that have been heated up to 900 degrees Celsius, and they're taken out to cool to 100 in an ambient air of 35 degrees Celsius. So first I found the Biot number to be less than 0.1, which makes us be able to use lumped analysis. Solved for LC, solved for the theta, the temperature change, which eventually could give us a T of 2.73 minutes. And then we know the heat transfer is going to be equal to MCP delta T. So you find the heat transfer for each ball and then multiply it by the 2,500 balls per hour. And then unit change to seconds for watts, just joules per second. For the next problem, I used Excel just to make it a little quicker for each temperature depth, but you still set it up the same way with a semi-infinite medium, because you can assume the ground's good insulation and constant properties. And since that far right term in the case 3 for the semi-infinite medium is greater than 4, the ERFC of a number greater than 4 is going to go towards 0. And so x is irrelevant in that case, and the exponent is relevant in that case because you're subtracting 0. So you can just make it smaller to that left part. Plugged into Excel, I have a photo attached with the PDF on how I set that up, and the temperatures at each depth is right here, summarized right there. Third problem, you have an ice block, and you're going to assume two-dimensional heat transfer and constant properties and the tau of greater than 0.2, which we will prove later. And you know the ice is going to start melting at the top because that's where the most surface area is exposed to the ambient temperature. Again, I used Excel. Pictures are in the PDF. I interpolated to find the lambda and A values, given the Biot numbers of the wall on the sides and the top. And so your semi-infinite surface is going to be going in the Z direction, up and down, and then your X and Y directions of the wall can just be considered walls. And that's why that theta value is squared. And all the equations here and all the calculations are on Excel for the answer of 19.4 hours. Finally, mass diffusivity. You have use table 4 to find the inverse of ERFC and interpolate to find that value. And then solve for X. Pretty simple calculation. Don't really have questions yet. I just need more practice on setting up the problems. And I'm sure that'll come as we do more problems. The test kind of interrupted the learning of half of this material and accelerated learning of the other half. But not too many questions right now.